sklearnnaivebayesBernoulliNB. Description: Bernoulli-NB is a naive Bayes classifier specifically designed for binary features 0 or 1. It assumes that each feature is independent of the others and calculates the probability of a given class based on the probability of each feature being present or absent in that class. It's particularly useful for text classification, where features represent the presence or absence of words in a document. Inputs: X a 2D array of binary features 0 or 1 representing the input data. Each row represents a data point, and each column represents a feature. Y a 1D array representing the target labels for each data point in X. Outputs: Self the trained Bernoulli-NB model instance. PredictProbX returns an array of probabilities for each class, given the input features in X. PredictX returns an array of predicted class labels for each data point in X. Steps: Training. The model calculates the prior probabilities for each class based on the frequency of each class in the training data. For each feature, it calculates the probability of that feature being present 1 and absent 0 in each class. Prediction. For a new data point, the model calculates the probability of each class based on the features present in that data point. It then assigns the data point to the class with the highest probability. Metrics. Accuracy: the proportion of correctly classified data points. Precision: the proportion of correctly classified positive samples among all predicted positives. Recall: the proportion of correctly classified positive samples among all actual positives. F1 score: the harmonic mean of precision and recall. Visualization plots. Confusion matrix: a visual representation of the model's performance, showing the counts of true positives, true negatives, false positives, and false negatives. ROC curve plots the true positive rate against the false positive rate for different classification thresholds. Precision recall curve plots precision against recall for different classification thresholds. Fine-tune parameters. Alpha: a smoothing parameter that adds a small value to the feature probabilities to prevent zero probabilities. Binarize: a threshold for converting features to binary values. Values above the threshold are set to 1, and values below are set to 0. Fit prior: whether to learn class priors from the data or to use uniform priors. Uncertainty methods. Confidence score: the probability of a data point belonging to its predicted class, calculated by the PredictProba method. Entropy: a measure of the uncertainty or randomness in the model's predictions, calculated as the negative sum of the probabilities of each class multiplied by their logarithms. Challenges and fixes. Challenge 1: Data sparsity. Bernoulli-NB can struggle with sparse datasets, where many features have a value of 0. This can lead to overfitting and poor generalization. Sample use case that resulted in Challenge 1: text classification with a large vocabulary, where many words are absent in most documents. Fixes to Challenge 1. Increase the smoothing parameter alpha to reduce the impact of 0 probabilities. Use feature selection techniques to remove irrelevant features and reduce data sparsity. Consider alternative naive Bayes models like multinomial NB, which are better suited for handling sparse data. Challenge 2: Class imbalance. Bernoulli-NB can be sensitive to class imbalance, where one class has significantly more samples than the others. This can lead to the model favoring the majority class. Sample use case that resulted in Challenge 2: fraud detection, where fraudulent transactions are much rarer than legitimate ones. Fixes to Challenge 2. Oversample the minority class or undersample the majority class to balance the dataset. Use class weights in the model fitting process to give more weight to the minority class. Consider using a cost-sensitive learning approach that penalizes misclassifications of a minority class more heavily.